Hi everyone, let's verify our inverse function rule graphically. Let's start by graphing the original function, y equals the cube root of x plus 5 all over 7. Y equals, parenthesis, the cube root of x, that's x to 1/3, plus 5 all over 7. That's the original graph of the function. My proposed inverse function is given by the cube of 7x minus 5. Y equals 7x minus 5 all cubed. The red graph and the blue graph better be reflections about the line y equals x. And yes, they are. For example, the y-intercept here is the x-intercept over here. Notice that both the red graph and the blue graph pass both the HLT and the VLT. These are both one-to-one functions. All right. Oh, and by the way, let's look at y equals x cubed, the tall proud snake. The inverse graph, y equals the cube root of x. Oops. X to the 1/3. Right. Okay, I claim that the red graph and the blue graph, sorry, the red graph and the green graph are inverse graphs. The line of reflection is y equals x, that purple line. And yes, the red graph and the green graph are reflections of each other about that purple line, y equals x. Looks like a DNA strand. With temperatures, so it turns out that this linear function converts from Celsius degrees to Fahrenheit degrees. Now you're going to show in the homework that the inverse function that takes you from Fahrenheit to Celsius is given by this rule. Now, when you graph the two functions, f and f inverse, f converts you from Celsius to Fahrenheit. For example, 0 goes to 32. F inverse converts you from Fahrenheit to Celsius. For example, 32 goes to 0. In fact, there's a table, rapidtables.com. That's a website. Okay, 0 degrees Celsius converts to 32 degrees Fahrenheit. Also, there's a Fahrenheit to Celsius page. 32 degrees Fahrenheit converts to 0 degrees Celsius. You see formulas in here. Right. Now, this idea of restricting domains and ranges, now there is a coldest temperature. And it's called what? It's called absolute zero or 0 Kelvin. In fact, you could argue that I should have open endpoints here. Although some physicists believe that absolute cold is the same as absolute heat. Go figure. Right. But sometimes you have to restrict domains and ranges. Again, these two graphs are reflections about the line y equals x, this slanted line. Oh, and this is an interesting point over here. The intersection point between the two graphs. That is the point, and it's on the line y equals x. That's the point -40, -40. What's the significance of that? -40 degrees Fahrenheit is -40 degrees Celsius, and vice versa. So it's the one number for which, if you say, brr, it's -40, it doesn't matter if it's Fahrenheit or Celsius degrees. It's the same temperature. Very cold. That's it.